Hi guys, welcome to lesson 18.2, which will start up on page 318 in your book. This lesson is all about formulas for geometric sequences. So we studied what a geometric sequence was, so that's a sequence that's changing by a common ratio, something getting multiplied over and over and over. And now we want to be able to write a recursive formula for that sequence and an explicit formula for that sequence. And then we're going to use one of our formulas, or either or both, to find a given term of a geometric sequence. So let's take a look at how some of those formulas look.
So a lot of vocabulary to know the difference between things and what the questions are asking us. Remember that the numbers in a sequence are called the terms, and you can use sequence notation, a sub n, or function notation, f of n, to refer to the nth term. So you can use either one, and we'll use both a lot so that you're comfortable using either one. So use the above notation to rewrite the first four terms of the viral video sequence. Also write the common ratio. So a sub 1, which is the same as f of 1. So this is sequence notation, this is function notation, and either one of those were 1. The first term in the sequence was 1. The second term, or a sub 2, f of 2, was 3, because she sent it to 3 people first, right off the bat. So that was stage 2. Stage 3, or the third term, or f of 3, was 9. And then the fourth term, a sub 4, or the function of 4, two different ways of saying the same thing here, was 27. And the common ratio was 3. So we want to know, what is the value of the term following a sub 4, also known as a function of 4. So what would be the next term? Write an expression to represent this term using a sub 4 and the common ratio. So it would be 3 times a sub 4, right, to get to the next term. So 3 times a sub 4, and it would equal, so if we look back here at 27, it would equal 27 times 3, which is 81. So 3 times a sub 4 would give us 81, and that would be the fifth term, right, because it's the term after a sub 4. Watch this stuff more than once if you need to. A lot of the notation, how math looks when you're trying to describe things, is what throws kids off, and they lose their taste for math because it's so complicated to look at. You just have to know. It's like learning another language. You have to just understand how to read what you're looking at. So we're going to look at recursive formulas now. And a recursive formula is a formula that gives any term as a function of the preceding term. So like we just called the fifth term 3 times the fourth term. So we're going to give it in terms of the term before it. So just as with arithmetic sequences, you can use a recursive formula to represent a geometric sequence. We're going to complete the table below for the viral video sequence. So a sub 1, or function of 1, the first term was 1. Okay. The second term, or the function of 2, was 3 times the one before it, so 3 times 1. And it equaled 3 times the first term. A sub 1 is the first term, which was 1. So we're showing it being multiplied by the value, and we're showing it being multiplied by the term before it. So 2 ways to say the same thing. So 3 times 1 in function notation would be 3 times f of 1. So here we're showing 3 times 1 is 3 times a sub 1, first term in the sequence. Here we're showing it as 3 times function of 1. So we're showing it in function representation, sequence representation. And at any rate, it was 3. So the third term would be 3 times the one before it, so 3 times 3, which would be in sequence notation 3 times the second term, and in function notation 3 times the second term of the function. So it was 9. So this one's going to be 3 times 9, which is 3 times the third term in the sequence. 3 times 9, which is 3 times the function of the third term, which was 27. And for a sub 5, or the fifth term, it would be 3 times 27, which is 3 times the fourth term in the sequence. 3 times 27, which is 3 times the fourth term of the function. And it was 81. 3 times 27 is 81. So then we get to, this is where you don't freak out, concentrate on the same pattern we've been doing. So to find the nth term, meaning any term that we want to plug in there, we're going to have to do 3 times the term before it. So it would have to be n minus 1. So 3 times the n minus 1 term, one term before the one we're looking for. So it would have to be 3 times the function of 1 before whatever we're looking for. So if we're looking for the 35th term, we'd have to do 3 times whatever the function at the 34th term is. So, and we put this blank here because we don't know what we want to plug in yet. I just noticed that I left off number 3, so I'm going to do it right here. It said the recursive formulas for the viral video sequence are partially given below, and they have this written: a sub 1 equals 1 and f of 1 equals 1. And they want us to complete the formulas by writing the expressions for a sub n and f of n. So a sub n would be 3 times a sub n minus 1, and f of n would be 3 times f of n minus 1. Now, they want us to write a recursive formula here on number 4, 5, and 6. We're going to write a recursive formula for each geometric sequence, and we're going to include the recursive formula in function notation, so not just sequence notation. So let's see. First, we'd say, well, a sub 1 is 64. That's where it's starting. So f of 1 is 64. So let's see, these are each changing by, it's dividing by 4, dividing by 4, dividing by 4. So we have to multiply by 1/4. So the ratio is 1/4. Just telling myself that. So a sub n, the nth term in the sequence, I would have to do 1/4 times a to the number before the one I'm looking for. A sub number before the one I'm looking for. And f of n would have to be 1/4 times f of the one before the term I'm looking for. So let's see, this one is getting divided by -4, -4, -4. So we'd have to, in order to divide, we'd have to multiply by a fraction. So I am going to take this problem and do it up here where I have a little room. So the first term is 64 again. So the function at the first term is 64. And then we'd have to say that the common ratio is -1/4. So a sub n would be -1/4 times a sub n minus 1, the term before this. And f of n would be -1/4 times f of the term before it. So for number 6 here, it looks like we're just multiplying by -1 every time, right? So the first term is -1. The first term of the function is -1. The ratio is -1. That's what's getting multiplied every single time. So a sub n would have to be negative a n minus 1, or negative 1 times a sub n minus 1. I'm going to usually leave a negative 1 off of it, so it would just be negative. So f of n would have to be negative, or opposite of the function at the term before the one I'm looking for. So this sounds very abstract, but this right here just means the one before the term I want. So if I want the 50th term, then I'd have to multiply negative 1 times whatever the value of the 49th term was. So that's where the n minus 1 comes from. It means we're doing this to the one before the one we're looking for. Let's see, we're supposed to use the recursive formula to find a sub 6, a sub 7, and a sub 8. So let's write down what the recursive formula was. It was 3 times the term before it. So we know that a sub 5 was 81. So a sub 6 would be 3 times a sub 5, or 3 times 81. So let's see, 243, I think, would be what we get there. So that would be 243. And then a sub 7 would be 3 times a sub 6, or 3 times 243, which would give us, getting bigger, 729. I'm giving you time. Make sure you're doing it yourself, right? A sub 8 is going to be 3 times a sub 8 minus 1, or a sub 7. Let me show that the long way. A sub 8 is 3 times a sub 8 minus 1, right? And 8 minus 1, since that's our n is 8, 8 minus 1 is 7. So this is the same thing as that. N, this is n, and so this is n minus 1. So in order to find the 8th term, we have to multiply 3 by the one before it. So that's going to give us 3 times 729, which is 2,187. So then it says, why might it be difficult to find the 100th term? You'd have to find all 100 terms by multiplying by 3, which would be very time consuming. You know what I mean? And besides, you want to talk about margin for error. If you just have it in your calculator and you're going times 3, times 3, times 3, what number am I on? Am I on 72? Am I on 99? That would be a nightmare. So we're going to learn how to do something better than this. So if we look at some patterns here, we can identify things that is going to help us write an explicit formula. So we know that a sub 1 in this viral video scenario, it's not always 1, but this one started with 1, and we know that the common ratio is 3. So the second term was 1 times 3 to the 1, because it was just 1 times 3, which was 3. The third term is 1 times 3 squared, and 3 squared is 9. The fourth term is 1 times 3 to the third, and 3 to the third is 27. So the fifth term, which was 81, which is 1 times 3 to the fourth. So we keep multiplying by another 3. So we keep multiplying by one more power of 3. So that was 81. And then 3 to the fifth was 243. And 3 to the sixth power was, oh wait, is this, sorry, pay attention. A sub 10 would be 1 times 3 to the 9th power. It's 1 power lower than the term we're looking for. So 3 to the 9th power, use your calculator, please do this by yourself. Pause it, because I'm about to say it. Hopefully you got 19,683. So yeah, be careful when we're reading along. I almost just assumed that this was a 7 right here, and it wasn't. Okay, so describe any patterns you observe in our response to number 9. And then use A sub 1, R, and N to write a formula for the nth term. So I think what we noticed is that any term, A sub N, would be the first term, A sub 1, times the ratio to the power of the term right before the one we're looking for. So this is a times. We could just write them in a row, but I'll use parentheses there. So really it looks like A sub N equals A sub 1 times R to the N minus 1. So if you notice that, so like the fourth term here. For the fourth term, we take the first, whatever A sub 1 was, the starting place, which was 1, and we multiply it by 3 to the, for the fourth term, I would do 4 minus 1, which is 3. So 3 to the power of 3. So for the sixth term, I would multiply 3 by the power of 6 minus 1, which is 5. So hopefully you see that pattern. So we want to write the explicit formula for the viral video sequence. Use the formula to determine the 12th term of the sequence. So if this is the generic formula right here, then for our viral video, it would be A sub N equals A sub 1 means the first term in the sequence, so the first term was 1, times, and then we're going to use our common ratio, which was 3 to the power of N minus 1. So that's the explicit formula for the viral video. And then they want to find the 12th term. So for the 12th term, we're talking about, this means the 12th term in the sequence. So it would be the first term times the ratio to the power of 12 minus 1. So A sub 12 would be 1 times 3 to the 11th power. And if you put in 11 powers, you're going to get 177,147. That's at stage 12. That's how many people have seen it at stage 12. That's what it represents. So what does it represent? The people who have watched it at stage 12. So it might help you to think of explicit formulas as functions. So the explicit formula for a geometric sequence can be thought of as a function. The input is n, and that is the term number. And the output is A sub n, which is the value of the term. So, like the first term was 1, but the second term was 3. So, if I put in a 2 for my term number, then my output, my A sub 2, would equal 3, because 3 people saw the video on stage 2. So the domain of the function is positive integers. It can't be negative, but because you can't have negative terms, right? And then rewrite the explicit formula for the viral video sequence using function notation. So instead of, this is the old one, A sub n equals 1 times 3 to the n minus 1. For function notation, it would be the function of n, the function at whatever term number you want, would be 1 times 3 to the power of n minus 1. So it's the same steps there, but instead of sequence notation, it's in function notation. So now we're going to use a graphing calculator to graph our function from part C, and then see if the function is linear or nonlinear, justify our response. So you're going to go to GeoGebra and put that in, and I'll make a separate link showing how to do that. Just since I'm on this, and so I don't have to forget, what we're going to find out is that this is nonlinear. And the justification is the graph, that's a semicolon, an ugly one, looks like a J. The graph is not a line. So let's go see what that looks like. So if you open GeoGebra, then down here where the input is where you'll enter. So our function for part C was f of n equals 1 times 3 to the power of, and for power you'll use your caret, your up arrow, n minus 1. So if you hit enter, it'll graph that for you. So you can see the function that you type down here in input show up here in the function area, and then that'll show you the function. So clearly that's why we said it was nonlinear.
So number 13 says, the function you wrote in item 11C is an example of an exponential function. An exponential function, oh, by the way, by 11C, I think it means 12C. An exponential function is a function of the form f of x equals a times b to the power of x. A can't be 0, and b has to be greater than 0, but not equal to 1. So it can't be negative, and it can't be 1, but it could be any fraction between 0 and 1, and anything bigger than 1. So what is the value of a in the function we wrote in 12C? Well, if you look back at that function, we had f of n equals 1 times 3 to the power of n minus 1. So in this case, the value of a was 1. That was that value right there, because here's the formula, and so a was right there. And how is it related to the viral video sequence? It is the first term. It's where it starts. The first term in the sequence. So this sequence started with just one viewing. What is the value of b? So in the case of our one up here, this is b, because b is the one with the power of x on it. So b equaled 3. And how is that related? And that is it is the common ratio of the sequence. How is the function you wrote different from the general form? Well, if you look at the one we wrote here in 12C, it's different from the general form because this is the general form. And in the one we wrote, the common ratio was raised to the power of n minus 1 instead of just a single variable. That says instead of just a single variable. So in the general form, it's raised to the power of just a single variable, which is usually x. So that's the difference.
Okay, so we're supposed to consider this geometric sequence, 5, 10, 20, 40, and write the explicit formula for the sequence. So hopefully we can tell that the common ratio is 2, and if we remember the generic version, it's the nth term will be a sub 1 times the ratio to 1 power less than the term we're looking for, our term number minus 1. So for this particular sequence, a sub n would be, the first term is 5, that's what a sub 1 is. So 5 times, the common ratio is 2, and it would be n minus 1. So how could we check if our formula is correct? We could plug in term numbers and see that we get the correct value. So if we look at like this term, this is a first term, second term, third term, fourth term. So if I try my formula for the fourth term, a sub 4 would be 5 times 2 to the 4 minus 1. So I would have 5 times 2 to the third, which would be 5 times 8, which would be 40. So that's an example of testing out how it works. So we want to determine the 16th term. 16th term would be first term times common ratio to the n minus 1. So 5 times 2 to the 15th. This is going to be rather large. So 2 to the power of 15. So I'd have 5 times 32,768, which would be 163,840. So then they want us to use, you can see how things go up pretty quickly in a geometric sequence. Use function notation to write the explicit formula for the sequence. So same thing, it's just that it's in function notation. So f of n instead of a sub n would be 5 times the ratio to the power of n minus 1. So I think function notation we usually use parentheses like that. So what is the value of f of 10? So if I plug in f of 10 would be 5 times 2 to the 9th, right? 10 minus 1. So 2 to the power of 9 is 512. So 5 times 512, which would be, please make sure you're doing this yourself, and then pause, check, fast forward, rewind, whatever, okay? And what it represents is the 10th term. F of 10 would be the 10th term of the sequence. So you can see this all started off rather confusing just because of the notation, but once you understand what the language is, what the little symbols represent, it's becomes pretty easy. So really, truly, try number 14 by yourself here, and actually 14 and 15. Pause this and then watch it and see if you were right. You can even fast forward it a little to see if you were right, and if not, you can listen to it carefully. But if you were right, you can just, cut to the chase. So let's see. You have already done it and unpaused it. So this is what you found out. Let's see, the ratio here is 1/2. So the explicit formula would be a sub n equals first term, 32, times 1/2 to the power of n minus 1. So if I want the 9th term, I would do 32 times 1/2 to the power of 8, because 9 minus 1 is 8. So that would give me, let's see here, if you put 1/2 to the 8th power in your calculator, it might just give you 0 because it's so small. So what we could do is 1/2 to the 8th power is 1/2 times 1/2 times 1/2 times 1/2. So what we'd end up with is 1 times 1 times 1 times 1 times 1 is still 1, but 2 to the 8th power is going to give us 256. So if we do it that way, can you figure out how I got the 256? 1/2 times 1/2 times 1/2, 8 times, or 2 to the 8th power on the bottom gives me 256. So if I do it this way, I'll get 32 over 256, and that will probably give me a better decimal that I could write down. So we'll end up with 0.125. I'm afraid that if you just put 1/2 to the power of 8 in your calculator, it's going to give you 0 because it's so tiny, 1 divided by 256. So there's a workaround for you. The explicit formula for geometric sequence is this here. And so we want to state the recursive formula for the sequence. Include the recursive formula in function notation. So going back to recursive, remember the first thing you have to do is say what a sub 1 is, which is the first term. And so f of 1, it's 6. And then a sub n would be 6 times a sub n minus 1. Nope. Sorry, that's a mistake. It's not 6 times, it's whatever the ratio is, 3. So r is 3 in this case. So it's 3. So a sub n would be the common ratio times the term before it. Okay? So f of n would be the common ratio times the term before it, f of n minus 1. So going back to recursive, so that was back a few problems before this, the recursive formula. It's the ratio times the term before it. So how could we use a recursive formula to write the explicit formula? We could identify, we'd need to know what the first term was and the ratio. And once we identified the values of those, then we could substitute them into the formula. So we're going to write the explicit formula, okay? Explicit, not recursive, for each geometric sequence. Then determine the 6th term. So pause this, do it yourself real quick. We'll make sure you're right on track. So I can tell that the ratio is 5. So the nth term would be first term times 5 to the n minus 1. So if I want, we're going to find the 6th term of each sequence. So a sub 6 would be 1 times 5 to the 6 minus 1, which is 5th power. And 5 to the 5th power is going to give us 3,125. And then this one, let's see, the ratio is negative, it's dividing by -2, so it's not -2, it's -1/2. So a sub n is going to be the first term, 48, times -1/2 to the power of n minus 1. So the 6th term would be 48 times -1/2 to the power of 5. And that gives me 48 times -0.03, or you can use fraction form, which is -1.5, or you could call it -3/2 if you were working with fraction form. All right, so let's see here. It tells us the first term, and then this is a recursive formula, so we can see the common ratio right here. So the explicit formula would be first term times common ratio to the n minus 1. So the 6th term would be -81 times -1/3 to the power of 5. And if I did this in the long way, like fraction form, let me show it to you. And this would be -81 times -1 times itself 5 times will just be -1, and 3 times itself 5 times would be 243. So if I multiply these together, I get 81 over 243, and that would reduce to 1/3. All right, so there's a lot of little components to it, telling the difference between recursive and explicit. What are the elements you need? What is the notation for sequence versus function and all of that? Not too hard to do, but a lot of stuff to memorize as far as vocabulary goes to be very comfortable with it. So bring your questions and we'll see you in class.